The diode is forward biased by applying a voltage across its junction. The N side of the diode is connected to the negative side of the voltage. This causes the negative charge, that is the electrons on the N side, to be repelled leftwards, like this. They gain sufficient energy and neutralize some of the positive charge in the depletion region. Similarly, holes also move from the p-type region towards the depletion region. But how exactly do holes move? The holes move because of vacancies created by electrons which move out of the valence shells. The holes themselves do not move in reality, only the electrons do, leaving behind the holes. So what exactly happens here? The electrons recombine with holes in p-type region when they migrate from the n-type. These electrons in their valence shells are pulled towards the positive terminal, the anode, by the positive side of the voltage V. You can see that via the blue dotted lines in the P region. They leave their shells for further migration, and in the process, holes start to travel rightwards, as we had initially talked about. This is important to understand. The holes move to the depletion region and neutralize some of the negative charge there. In reality, this is caused by more electrons leaving for the positive side of the voltage. Remember that holes do not move, only electrons do. This neutralizing of the depletion region causes the region's width to decrease. This also causes the barrier voltage to decrease. It is lowered by an amount equal to the biasing voltage V. This causes conduction to happen. The region shown here is the forward bias region. The diffusion current ID increases. Why? Because more and more electrons are diffusing through the barrier. The saturation current IS remains the same as it is independent of barrier voltage. According to this formula, I equals ID minus IS, the current I also increases, and this is the equilibrium state. To get this formula, apply Kirchhoff's current law here at this terminal. Current entering I and current entering IS are equal to the exiting current ID. Hence the formula.